This is our first video of covering the formative assessment from this month. It was about solving exponential and logarithmic equations, and it began with just a little assessment of how you use the laws of exponents to rewrite exponential expressions. And that's what these first four problems are about on this assessment. And the directions say to rewrite each of these expressions as a single power of 2 and follow all the intermediate steps or demonstrate all the intermediate steps. So we'll just go through these four problems one at a time. First of all, 1/32, I'm going to notice that 32 is a power of 2. If you don't remember that, then just have a little bit of faith that you can actually write each of these things as a single power of 2, and just run through your powers of 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times another 2 is 32. So if I multiply 5 2's, I get 32. So that means that this is the same thing as 1 over 2 to the 5th power. And so this is a little more than just a single power of 2. It's a fraction with a power of 2 in it. But you'll remember the negative exponent rule. I can write this as a single power of 2 if I'm allowed to use negative exponents, which is just fine in this problem. So 1/32 is 2 to the negative 5th power. The next one gets a little trickier. You will notice we already have a power of 2 in here, and somehow we need to combine these things so that we end up with a single power of 2. And I will begin by just rewriting the 4 as 2 to the 2nd power. And so I can rewrite this product as 2 to the 2nd power times 2 to the n. And this is a pretty clear opportunity to use the product rule of exponents. If I multiply 2 times 2, and then I multiply by another n 2's, then in total, this expression is basically multiplying n 2's and then another 2 of them. So I can say that this product is 2 to the power of 2 plus n. And that is a single power of 2. It's just a base of 2 raised to some power, in this case, 2 plus n. They get progressively more challenging as we move to the right, but still very manageable, I think. You notice that 2 to the x, that's already written as a power of 2. And then 8 is a power of 2. It's 2 to the 3rd power. So I might begin by just writing my expression as the quotient of 2 powers of 2. And then, of course, I can use my quotient rule. If I multiply x 2's on the top, and then I divide out 3 of those 2's, it's like multiplying x minus 3 2's. So I can apply the quotient rule here and just say that this is 2 to the power of x minus 3. And finally, I have 2 bases here, 8 and 4, that are both powers of 2, each of them raised to a different exponent. So I'll start by just representing these bases as powers of 2. On the top, I get 2 to the 3rd power. Once again, that's 8. And I'm going to raise that to the power of x. And then I'm dividing that by 2 to the 2nd power and raising that to the power of y. That's the same thing. It's just 8 to the x over 4 to the y. Now this is called a power of a power. That's what I have on top here, and I have another one on the bottom. And so I can use the power rule to rewrite this. Just multiply the 3 times the x. Now my exponent for this entire thing without the parentheses is 2 to the 3x. And I'm dividing that by 2 to the 2y. And all together, I can again use the quotient rule here and just say this is 2 to the power of 3x minus 2y. And that is it.